a central angle. A central angle is an angle whose vertex is at the center, and it's formed by two radii. So if the center of our circle here is O, so any two radii that we have would be, again, have endpoints from the center to the endpoints on the circle. So we'll call this AB. So we would say that angle AOB is a central angle, because notice that the vertex is at the center. The next is a minor arc. A minor arc is an arc whose measure is less than 180 degrees. It is named with two letters. So for this one, the minor arc we could say would be AB, or you could say BA, doesn't matter what order. So that minor arc is this little piece right here. Then we have the next piece, which is the major arc. So minor arc is less than 180 degrees, and a major arc is an arc whose measure is more than 180 degrees, and it's named with three consecutive letters. So for this one, this from here to here would be a major arc, because that would be more than 180 degrees, because think about what would be 180 degrees. That would be half of your circle, because a full circle is 360. So as long as it's more than half your circle. And so then for this, we would name this with three consecutive letters. So we could say arc ADB, or you could say arc BDA. Again, you could do the reverse order would also work. And this next one is a semicircle, an arc whose measure is 180 degrees, so it has to be equal to 180 degrees. So for this, you can see that the diameter has to be right here, so it would go through. You can see that we know that the diameter tells us that this arc right here would be half the circle. Or of course, you could use this side over here as well. So if we do this top arc and name it, we would say this is arc ABC, or you could say arc CBA. And if you did the one that's yellow, you could say ADC, so that arc, or arc CDA. So for the next one, an intercepted arc is the portion of a circle that is cut off by the angle. So the intercepted arc here would be right here. So we would say that AB, or arc AB, is the intercepted arc for angle A, and this is a D, so ADB. So make sure you know all of those definitions. And of course, we have that formula sheet, so you could start adding stuff to your formula sheet. So we talked about the central angle. So that's something you would want to add to your formula sheet. So let's go to the next part. So the next one is the arc addition postulate. So this states that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So we're going to write the postulates for the points on circle P. So that would be then arc AB plus BC arc is equal to arc AC. So this plus this arc by our arc addition postulate states that is equal to the total from here to here. So we're going to use this to find the requested information. we want to find the measure of arc MO, so that would be from here to here. So to find that, we're going to add 97 degrees plus 26 degrees, which gives us arc MO, which is equal to 123 degrees. And make sure you always label everything with a degree symbol. That's important. For the next one, we want to find the value of x, given that this arc PQR, so from here to here, is 120 degrees. So we know that's 3x plus 18, add that to 2x minus 3, and that should be equal to 120 degrees. So we're going to combine our like terms. So we get 5x plus 15 equals 120 degrees. And then we want to subtract the 15 and divide by 5. So you would end up with x being equal to 21 degrees. So it doesn't ask for what P, Q, and QR are equal to, but you could easily find that. So if I plug in 3 times 21 plus 18, then you can see that arc PQ is equal to 81 degrees. And if I wanted to find arc QR, that would be 2 times 21 degrees minus 3, which gives us QR being equal to 39 degrees. All right, so the next part says recall that the degree measure of a circle is 360 degrees. Each minor arc of a circle is associated with and determined by a specific central angle. The degree measure of a minor arc is the same as the degree measure of its central angle. So that is very important. For example, if the measure of central angle PRQ is 30, then the degree of its minor arc PQ is equal to 30. Using symbols, this can be expressed as the following. Angle PRQ is a central angle, and angle M, and the measure of angle PRQ equals 30, then the measure of the arc PQ equals 30 degrees. So if we just draw a quick circle, to show what they're talking about here. So there is my central angle. I'm going to call this AOB. So they're saying that the measure of angle AOB is equal to the measure of arc AB. So this is the arc, and again, this is the actual angle. So we're going to use that to help us find these answers. It says find the measure of the arc, then identify the arc as a major arc or minor arc or semicircle. So if we look at the first part, we have arc M. So MN would be this part right here. So notice that is intercepted by this angle measurement, which is 68 degrees. So that means that this arc is also 68 degrees. And this, of course, would be a minor arc because it's less than 180 degrees. Then we want to look at the next one is arc KLN. So K to L to N, you always want to go in order. So if I look at that, notice that K to N is a diameter. So that means this is half of the circle. So that means that measure would be 180 degrees, which is a semicircle. And then we want to look at the next one is arc LM, which is this arc right here. So if we know that this entire arc is 180 degrees, this intercepted arc right here, this is a central angle, so that's 87 degrees, which means this is 87 degrees. And we know that this arc MN is 68 degrees, and we're solving for x, so we would add those together. So we would have 87 degrees plus x plus 68 degrees is equal to 180 degrees. So we would get x plus 155 degrees equals 180 degrees. And then when you subtract, you get x is equal to 25 degrees. So this would be 25 degrees. And of course, that is a minor arc. And then we want the next one is JLN arc. So JLN would go this way. So let's go ahead and erase some of this. JLN. Okay, so we said that this one right here, I'm going to write 25 degrees. So we know that 87 plus 25 plus the 68 gives us 180 degrees. And we want to figure out what then this is equal to. So we can use the fact that we know we have vertical angles that are the same. So I can see that this angle here and this angle here are what we call vertical angles because they're across from each other. So that means that this angle and this angle are going to be the same measure. So that would be 68 degrees, which means that this arc length is also 68 degrees. So if we add up for JLN, that's going to be, I'm going to write it here, so 68 degrees plus 87 degrees plus 25 degrees plus 68 degrees. That gives us 248 degrees, which is a major arc. And the next one we want to find is this arc measure right here, which is JN. So we know all the degrees in the circle add up to 360 degrees, and we just found that the arc JLN, which is the one in yellow, 248, we can subtract 360 degrees minus the 248 degrees, which gives us 112 degrees. Of course, that's minor arc because it's less than 180 degrees. And then the next one we want to find is arc NJL. So N to J to L would be from here all the way around. So we just need to add up those values that we found. We just said this is 112 degrees. So 112 plus 68 plus 87 gives us 267 degrees, and that is a major arc. All right, for the next part, we're going to, given the arc measure a name the arc. So for 108 degrees, we can see that's from here to here. So that's arc BC, or you could say arc CB. It doesn't matter which order you write that in. 79 is arc AE, or again, you could write EA. 61 degrees would be DE or ED. The inventor would be right here, so that would be arc AB or BA. Athlete or other, or athlete and other, would be from here to here. So that would be arc CE. And if we did actor, inventor, and musician, we could say that we have to use 3 letters for this one because it's more than 180 degrees. So I could use CAE, you could do CBE, or of course you could do the reverse for that. So that is it for those. Let's go ahead and look at the next question that says, find the value of x in each problem. And so x in this case is this length right here. So if I want to solve for x, notice that says this is a 90-degree angle, and it looks like this is a diameter. And of course, if that's 90 degrees, that means this is 90 degrees. And by our central angle definition, we know that the angle measurement is the same as the arc, so that would be 90 degrees. For this one, if we're finding x, that means we're looking for this measure here. So again, then x would be equal to 162 degrees because the arc is the same as the central angle measure. Here, if this is 113 degrees, and we see that h is the center, so that means kj, the core that goes through h, that's a diameter. So we know that from K to J, that is going to be 180 degrees. So if I want to find x, x is equal to 180 degrees minus 130 degrees, which means x is equal to 67 degrees. For the next one, 14, solving for x. So here we know that if this is 141, then the arc is 141 degrees. And we know that the full circle is 360 degrees. So that means x is equal to 360 degrees minus 141 degrees minus 72 degrees. So x equals 147 degrees. For the next one, if this is 137 degrees, and again, a full circle is 360, so you know this is 137 degrees as well, but x equals 360 degrees minus 137 degrees, so x equals 223 degrees. And for the last one, we're given that this angle is 120 degrees, and we want to find this arc, which we're given is 4x plus 48. So you know 4x plus 48 must be equal to 120 degrees. So subtract 48, you get 4x equals 72 degrees, divided by 4, and x equals 18 degrees. So that is it for our circle vocabulary and central angle measures, and again, those other arc definitions that we looked at as well. So that's it. Make sure to also fill out the graphic organizer.